Recitation Worksheet 4 is for empirical formula and dilution and molarity. Okay, so we're going to start with finding some empirical formula and molecular formula. So the first question, we have a compound. It has nitrogen and hydrogen with this percent composition by mass, and we have the molar mass of the actual compound. So we have to first find the empirical formula, and then from the molecular formula that we have, we can find the molecular formula. Okay, how do we do that? In all of these kind of questions, we assume we have 100 gram of the compound if we have percentage. So if we get the percentage of each element, you assume you have 100 gram of the compound, then these percentage turn into the mass of each element. Okay, so if we have 100 gram of the compound, we have 87.5 gram of nitrogen, and we have 12.5 gram of hydrogen. That's the first step, right? The second step is to convert the masses to the mole, because we want to know how many of each element we have, and then we say how many we have to find the moles, because mole is the counting unit. So you want to count them. You cannot compare them based on the mass. You have to do it with moles. So we convert them to moles. The mass of nitrogen is 14.007 gram is 1 mole. And for hydrogen, I want to get rid of this gram, so I put it on the bottom, and I want mole of hydrogen. And from the periodic table, you know that 1008 gram is 1 mole of hydrogen, and that gives you 6.2469 moles of nitrogen and 12.4008 mole of hydrogen. So that's the second step. The third step is to divide them by the smallest number you get. So you have 6 and you have 12, so 6 is smaller, so you divide both of them by 6.2469, and you do it for both of them. Both of them should be the same number, 6.9. Okay, so this is 1, this is almost 2. Okay, so if you get 1.98, 1.99, it's very close to the whole number. You round it to the whole number. If it's less than 1.9, you cannot round it. You have to keep the number. And that goes to the fourth step that we talked about in the lecture slides, that you have to multiply it by a common factor until you get a whole number. But if you're really, really close to a whole number, just round it to a whole number. So this tells us that we have 1 nitrogen and 2 hydrogen in each molecule. Okay, so NH2 is our empirical formula. The empirical formula. We want to find the molecular formula. So how do we find the molecular formula? We have to find the molecular formula of the molecular weight of the empirical formula. So we have 1 nitrogen. Nitrogen is 14.007, plus we have 2 hydrogen, so 2 times 1.008, and that is 16.023 gram per mole. So this is the molar mass of the empirical formula, but the actual molar mass of the compound is 32. So you divide that 0.46 gram per mole by the mass of each empirical formula unit. So you can get rid of the units, and this is 2. So which means you have 2 unit of the empirical formula as the molecular formula. Therefore, the molecular formula is N2H4. So that's the molecular formula. Okay, so let's do the next question. If you have a compound, it's an ore, analyzed and found and contain these three elements: aluminum, nitrogen, and oxygen. You have these percentage by mass. So the first step, consider you have 100 gram of the compound. Therefore, each of these three can be counted as the mass of each element: aluminum, nitrogen, and oxygen. So we have 12.7 gram aluminum, we have 19.7 gram of nitrogen, and we have 67.6 gram of oxygen. So the second step is to convert the mass to mole. So you find the mass of each element from the periodic table. Aluminum is 26.982 gram in 1 mole. Nitrogen is 14.007 gram is 1 mole, and oxygen is 15.999 gram in 1 mole. Therefore, you have 0.4709. I always write 4 decimal places, and you've learned this in the significant figure processes. Like if you have multi-step process, always keep 4 decimal places, and if you need it in the end to round it, you can round it to the last step. But here we have a division, so I keep 4 decimal places. So this is 1.4064, and these are mole, right? All of them are mole. And for oxygen, we have 4.2253 mole. Okay, so we move to the third step. Divide them by the smallest number. So you have 4 point something, 1 point something, and 0.4. Okay, so this one is the smallest. Therefore, we divide all of them by the same number and the smallest number that you find. So all of them should be divided by 0.4709. 0.4709. So you will get 1 from this one. This is almost 3, and this is almost 9. Okay, so your empirical formula, you have 1 aluminum, you have 3 nitrogen, and you have 9 oxygen. Okay, so that's your empirical formula. Okay, to find the molecular formula, we have to find the molecular mass of our empirical. So 1 aluminum is 26.982 plus we have 3 nitrogen, so 3 times 14.007 plus we have 9 oxygen, 9 times 15.999, and that is equal 212.994 gram per mole. So then you have to compare this with the actual molar mass, and you see in the question that the molar mass is exactly the same number as we find the molar mass for the empirical, which means the molecular formula is the same as the empirical formula. So this is both empirical formula and molecular formula. Both of them are aluminum, nitrogen 3, oxygen 9. If you think about the polyatomic ions that you have to memorize, we had nitrate, right? So this compound is actually nitrate 3. So you've learned how to name the ionic compound, right? So how do we name this? aluminum nitrate, and you know aluminum have 3+ charge, right, that we don't write. Aluminum nitrate. Okay, so this is aluminum nitrate, but this is chemical formula. So let me write this. This is chemical formula. This is empirical formula or molecular formula. So you cannot take this one as molecular formula, because in molecular formula we simply find out how many from each element and we write it this way. Okay, so do not use this as the molecular formula. This is chemical formula. So in a chemical formula you get more information as how these atoms are bonded together. Okay, so let's go to the next question. We have another example for finding the empirical formula. So in this example we have 0.6 gram of the compound, and we have the mass of each element. Okay, so in this question we do not have percent by mass, and we don't need to find the percent by mass. So if you think about it, in the previous question, since we did not have the mass of each element, we assume that we have 100 gram of the compound, therefore we can take those percentage as the mass of each element. In this question we already have the mass of each element, so we know how much AS do we have and how much O do we have. Okay, so we use those numbers and convert them to moles, just like what we do in the previous question. So step 1 is to find the mass of each element, and we already have the mass of each element. So arsenic 454 gram and oxygen 0.146 gram. So you multiply, you have to convert them to moles. That's the second step, gram to mole. And if you check the periodic table, the molar mass, the atomic mass is 74.922 gram is 1 mole, and oxygen is 15.999 gram is 1 mole. So this one is 0.06060. This one is 0.009126. Okay, so you have to divide it by the smallest number. So which one is the smallest? You have 0.06009, so 6 is smaller, so you divide both of them by this number, 606. So this one is exactly 1. This one is almost 1.5. Okay, so you might get 1.498 ish, something like that. So you just can take 1.5. Okay, you cannot round this number to 2 or 1. Okay, we say we round it to a whole number if it's very, very close to the whole number, but if it's not, we just keep it like that. Okay, so this is where we have the fourth step. So if it's not a whole number, we multiply it until we get a whole number. Okay, so if you multiply this by 2, you will get 3. Okay, that's a whole number. So we take 2 and you multiply these as 2 by 2 as well. So this is 2 and this is 3. So therefore the empirical formula is AS2O3. And I think we just need the empirical formula in this question, because yes, we do not have the molecular mass, because we need the molecular mass if we want the molecular formula. Okay, so we just want the empirical formula, and that is the empirical formula. Okay, so let's go to the next question. So we move to molarity and dilution questions. So the first one is What is the molarity of a solution that has 25.5 gram of KBr? And you know how to name this, right? This is potassium bromide. Okay, it's an ionic compound. Potassium bromide dissolved in 1.75 liters of solution. Okay, you know how to find molarity. It's mole over liter, or sometimes you write it like N as the number of moles over V as the volume in liter. Okay, so we need the mole of the solute. We have the mass of the solute, we have the mass of KBr, so we have to convert that to moles, right? So let's write it. We have 25.5 gram of KBr, and we don't want the gram of KBr, we want the moles of KBr. So we can use the molar mass of KBr, and the molar mass is 119.00 gram is 1 mole, and that is 214 moles of KBr. Okay, now we have moles, so we have that. We need the liters. Do we have that? Yes, the solution is already in liters. Okay, so we have both of them, therefore the molarity is the moles of the solute, which is 0.214 mole, over the liter of the solution, which is 1.75 liter, and that makes the molarity as 0.122 molar or mole per liter. Okay, in this kind of question you can find the moles separately and then put it there, or you can just write everything in a one step. So you know, you want the mole, you have the mass, so you write everything in the same place, just like that. I mean, some students are feeling more comfortable with this type of writing, so they know what what goes where, and you can see the units cancels, and then you get the same answer. So there is no difference. Whichever you feel more comfortable, you can do that. Okay, so next question is a dilution question. Sulfuric acid is found in some type of batteries. Okay, what volume of 3.5 molar H2SO4, and you know that's a sulfuric acid, polyatomic ions, this is sulfate, and with H2SO4 it's sulfuric acid, is required to prepare 250 milliliter of 1.25 molar H2SO4. So how do you know it's a dilution question? So you have the same solution, you have the same compound, both of them is sulfuric acid, and you have two concentration and one volume. Okay, so therefore you know it's a dilution question, because you have 3.5 molar, and then you reduce the the concentration to 1.25, so it's less concentrated solution of the same compound. Okay, so therefore it's diluted. So you have two conditions. The first condition is, it doesn't matter which one you take the first, but usually the more concentrated one is the initial condition. So you know the concentration, and this is more concentrated, it's 3.5 molar. You don't know what volume to take, and the new condition is you have the concentration of 1.25 molar, and the volume, you know, it's 250 milliliter. Okay, the dilution equation is M1V1 equal M2V2. This is 1, this is 2, so we have both M2 and V2 we do have M1. We are going to solve it for V2. Okay, so if you divide both of them by M1, so you can cancel here, and V1 is M2 V2 over M1. Okay, and you don't need to convert the volume because we have volume on both sides. If you keep it as milliliter, you will get your V1 as milliliter. Okay, so we do use the milliliter as the unit. So M2, this is 2, so M2 is 1.5, so 1.25 molar times V2, which is 250 milliliter, divided by M1, which is 3.50. So the final volume is, let's see, if you put that in the calculator, your final volume is 89.29 milliliter. Okay, so you need to take 89.29 milliliter of your concentrated solution with this concentration, and then you add enough water to it until it reaches 250 milliliter volume, and at that time the concentration is 1.25. That's how you dilute your acid. Okay, the last question, I think it's the last one. Yes, the last question. A 25 milliliter solution is 0.5 molar HCl. Okay, what is the concentration after 25 milliliter of water is added to the solution? Okay, so you add water to something, you're diluting it, so it's a dilution reaction, dilution question. So let's write down the condition. Okay, so you have your first condition, you have M1 as 0.500 molar, and you have your V1 as 45.0 milliliter. Okay, so you add water, and you have your M2, we don't know, that's what we're asking. The V2, what is V2? Is it 25? No, it says we add water. Okay, so we are adding water is added. Okay, we are adding water to the initial volume, so we had 45 and we are adding 25, so V2 is the sum of both of them. So 45 plus 25 is 70 milliliter. So that's our V2. Okay, so we have all of them. We are solving it for M2. So M1 V1 equal M2 V2. Solving it for M2 is M1 V1 over V2. So I just skip this part. So if you divide both of them by V2, you can cancel these two, and this is how we get it. So M1, we have it from here, it's 0.500 molar, and V1 is 45.0 milliliter. V2 is 70.0 milliliter. So we can get rid of these two and you end up with molar, and the final answer is, let me see, 0.321 molar. That's the concentration of the acid when we add 25 milliliter of water to it.